Hello everyone, welcome to the video explanation for Brian Passwater's topic 3-8 notes, example 5. Example 5 says find the values of the following expressions using the unit circle. I have provided a handwritten unit circle there at the bottom right, but again these are values that we should have already memorized for sine and cosine. Remember that the x coordinate of each point is your cosine and the y coordinate of each point is your sine. This is important because tangent of any angle is defined as being its slope. Well, slope means that we're looking at the change in y over the change in x, which means that we are looking at sine divided by cosine for each of these angles, or y divided by x. So as we go through each of these problems, what we're going to be doing in our head is we're going to be figuring out what the quotient of sine over cosine would be. So for instance, for the tangent of pi over 6, that is the sine of pi over 6 divided by the cosine of pi over 6. So we would go to our unit circle and we would find pi over 6, realizing that the y-coordinate, 1/2, is the sine, and the x-coordinate, √3 over 2, is the cosine. Now, using algebra, we can reduce that complex fraction by flipping the bottom fraction and multiplying, which would give us that the 2's on top would cancel as well. Our answer here would be 1 over the square root of 3, which could be reduced or fixed to √3 over 3. In terms of multiple choice, it's important for us to realize that 1 over the square root of 3 is equivalent to √3 over 3. In terms of algebra, we always want to make sure that our answer is in simplest form and in appropriate notation, which would be that √3 over 3. Now, some calculators fix that automatically. Others require you to know that you're supposed to be rationalizing the denominator, which would give you 1 times √3 over √9, which again is √3 over 3. Now, it's worth noting that the tangent of pi over 6 has the same absolute value as the tangent of 5 pi over 6, 7 pi over 6, and 11 pi over 6. The signs of that value, however, would depend on which quadrant that we are in. Remember that since tangent is the quotient of sine and cosine, the sign of tangent will depend on the values of sine and cosine. If we are in quadrant 1, sine and cosine are both positive, which means tangent will be positive. If we're in quadrant 2, x is negative and y is positive, meaning we're doing a positive divided by a negative, means your tangent value in quadrant 2 would always be negative. In quadrant 3, you're doing the x and the y are both negative, so a negative divided by a negative would be a positive, meaning tangent would be positive in quadrant 3. And in quadrant 4, x is positive and y is negative, so you're doing a negative divided by a positive, meaning that in quadrant 4, tangent would be negative. So you'll notice the first 3 questions of this example ask you to find the tangent of your 3 major angles in quadrant 1. This is so that you would only have to do the math portion of this, where you have to actually find the tangent value once for each of these major angles, because then, just like sine and cosine, symmetry and knowledge of your quadrants should allow you to quickly come up with these values for the other quadrants. So for instance, the tangent of pi over 4, well, we've already stated that that is the sine of pi over 4 divided by the cosine of pi over 4. Both of those values are √2 over 2. Now we can do a lot of fancy algebra here, or we can realize that when we divide √2 over 2 by √2 over 2, that's like any other number divided by itself. That value is 1. The tangent of pi over 4 is positive 1. Tangent of pi over 3, again, that's the sine of pi over 3 divided by the cosine of pi over 3, which is the y-coordinate of pi over 3's point over the cosine, which is the x-coordinate. So that would be √3 over 2 on top, divided by 1/2. Again, to simplify that, we would multiply by the reciprocal of the denominator. The 2's would cancel, and we would be looking at the square root of 3 over 1, or just the square root of 3. So, again, it might be worthwhile for you as students to memorize that the tangent of pi over 6 is √3 over 3, that the tangent of pi over 4 is 1, and that the tangent of pi over 3 is root 3, because those values will follow the same symmetry rules as sine and cosine into quadrants 2, 3, and 4. All right, so the tangent of 5 pi over 6, well, again, that is the sine of pi over 6. I'm sorry, the sine of 5 pi over 6 divided by the cosine of 5 pi over 6. That would be 1/2 divided by negative root 3 over 2. We saw that math earlier. We know that that is equivalent to root 3 over 3. The difference being that since one of those two numbers is negative, our tangent would be negative. And again, that's in quadrant 2, so we should know that in quadrant 2, cosine is negative and sine is positive. So when we divide sine by cosine, we're doing a positive divided by negative, which is a negative. Otherwise, it would have the same value as its reference angle from quadrant 1, pi over 6. So negative root 3 over 3. 4 pi over 3 is located in the third quadrant. So when we go to do our sine divided by our cosine, it has the same coordinates as pi over 3, except they are both negative. So we would be doing the y coordinate, which is negative root 3 over 2, divided by the x coordinate, which is negative 1/2. Now again, we saw that work earlier in part C. It is a negative divided by a negative, which is a positive, meaning it would also be, just like part C, the positive square root of 3. Again, in quadrant 3, tangent would be positive because it is y divided by x, and in quadrant 3, both y and x would be negative. A negative divided by a negative is always a positive. Okay, letter F says 7 pi over 4 for our tangent value. Well, 7 pi over 4 is located in quadrant 4. The sine is negative root 2 over 2. The cosine is root 2 over 2. Those are the same number except one of them is negative, so that tangent should be negative 1. Okay, again, in quadrant 4, we should know tangent will be negative. All right, now the last three, they are different because they are dealing with your quadrantal functions, your positive x, positive y, negative x, and negative y axes that pass through those points 1, 0, 0, 1, negative 1, 0, and 0, negative 1. So the tangent of 3 pi over 2, remember that is the sine of 3 pi over 2 divided by the cosine of 3 pi over 2. Well, if we look at that point on the negative y-axis there, that is the point 0, negative 1, which means we would be doing negative 1 divided by 0. We are not allowed to do that. That is undefined. You are not allowed to divide by 0, so the tangent of 3 pi over 2 is an undefined value. For pi, the sine of pi divided by the cosine of pi would be, again, the points from our negative x-axis. We have that point negative 1, 0 that is on the unit circle. So our sine is 0 and our cosine is negative 1. Well, 0 divided by anything is 0. So the tangent of pi is equal to 0. Finally, for pi over 2, the sine of pi over 2 divided by the cosine of pi over 2. That is the same argument as 3 pi over 2, except the sine is positive 1. It's still divided by 0, which is undefined. So we would say that the tangent of 3 pi over 2 is undefined. So that's how we find tangent values. We think to ourselves, what's the sine, what's the cosine, and we carry out division, sine divided by cosine. Now remember that if you manage to memorize your tangent values for quadrant 1, those values do follow the same symmetry rules as sine and cosine into quadrants 2, 3, and 4. Tangent is positive in quadrants 1 and 3. It is negative in quadrants 2 and 4. And that all comes back to the signs of sine and cosine.